Hi, boys and girls. Today we're going to be starting our first lesson in Chapter 9 called Independent and Dependent Variables. This is kind of a tough lesson, so you're really going to have to listen. I'll try to slow down a little bit, which might make this video longer, but please just listen to what I have to say today, okay? So our I can statement for today is that I can find the independent and the dependent variable to then write an equation. So we have been working with equations. We've been solving equations. Now we're going to actually write an equation based on the independent and dependent variable. So first of all, let's start with what is an independent and what is a dependent variable. Here it says in our book that you can use an equation with two variables to represent a relationship between two quantities. One variable is called the independent variable, and the other is called the dependent variable. The value of the independent variable determines the value of the dependent variable. All right, so it's like, what in the heck does this mean? Well, let me tell you. An independent variable in an equation or a story problem in particular, we're going to be working with story problems this entire unit, is the variable or the thing that happens that makes the dependent variable happen. Okay? That's very complicated. I know, but just give me a moment, okay? All right, so let's take a look at this first problem, and maybe I can help you understand what an independent and a dependent variable is. So let me pull this up here for you. Pull this one off a little bit. All right, the book says Jerry burns 5.8 calories for every minute she jogs. So you know what jogging is, going outside and jogging, correct? Okay, identify the independent and dependent variables in this situation. Then write an equation to represent the relationship between the number of minutes Jerry jogs and the total number of calories she burns. Okay, so let's use this problem to start thinking about what an independent and a dependent variable is. Okay, we're going to let C represent the total number of, we're going to say calories. Give me a second here. Spelled right. Oh, kind of messy there, but oh well. And M is going to represent the minutes that she jogs. Okay? So let's think about this. Take a look at this little blue sentence right here. It says, think the total number of calories Jerry burns depends on the number of minutes she jogs. Okay? So the total number of calories. So if she doesn't go jogging at all and doesn't jog any minutes at all, is she going to burn any calories? Well, the answer to that question is no. She is not going to burn any calories. So it's the independent variable is going to be the minutes that she jogs. Okay, I'm going to put an M here. The dependent variable is going to be the calories that she burns. So she has to jog first before she can burn any calories. Does that make sense? Okay, so the other thing that I want to talk about that the book doesn't go into at all is this item right here, 5.8 calories. 5.8 calories is actually called something called a constant. I know I'm writing over stuff, but that's okay. A constant is something that is just in the problem that I need. It's not going to change. Well, it'd be like the speed that you would go, or for instance, the calories that she is burning is the same for every single minute. Okay, so that's kind of important. It helps us to identify. It helps sometimes to identify that independent and dependent variable. So now I'm going to write an equation based on this situation. Right here, 5.8 is right here. This is the constant. Now notice there's an equal sign right here. You see the equal sign? So here's the thing. The dependent variable is going to be by itself. We'll just put dependent, DEP for dependent. The total calories burned, okay, is equal to 5.8 times the number of minutes jogged. So right now, I'm going to have two variables because I don't know how many minutes she jogged. That's not what's important. I don't know how many calories she's going to burn. That's not what's important. What's important is putting the independent variable and the dependent variable into an equation so that I can solve it if I can identify the minutes, okay? All right, so the minutes was the dependent variable, so that is going to go here. So I'm going to have 5.8 times m, which is the minutes. This together will create the dependent variable, which is c. Okay, so the equation, okay, it's not enough room for me to write this. I'm going to write it over here. The equation c is equal to 5.8 times m, okay, represents the number of calories Jerry burns if she jogs m minutes, where c is the dependent variable and m is the independent variable. Okay, I realize this is really confusing, and I realize you're probably thinking, wow, that's really out there. And that's okay. We're going to do another problem here on the next page in just a moment so that you can have another picture of what independent and dependent variables are. Are you ready? All right, take a look at page 492 right now. Put it up here so you can see it. Let's take a look at this problem with Lorelai. Okay, Lorelai is spending the afternoon bowling with her friends. Each game she plays costs $3.25, and there is a one-time shoe rental fee of $2.50. Okay, picture in your head. I've told you before to picture in your head story problems. Put yourself in for Lorelai. Think about going down to the bowling alley and going bowling with your friends. Every game you play is $3.25, and then you have to rent shoes. Make sense? Well, $3.25 and this shoe rental, that is a constant, okay? What we need to do is we need to figure out the two things that are going to be dependent on each other or that will change, and they're going to be fit into my equation. So I'm going to identify the independent and the dependent variables in this situation. Okay, the dependent variable depends on the independent variable. It's the change agent. The dependent variable is the one that's going to change because of the independent variable. Okay, so again, here's this blue. Let's take a look at this blue sentence. It says the total cost that you're going to pay to go, or Lorelai's going to pay to go bowling, C, depends on the number of games. So in other words, if I play 5 games, it's going to cost a certain amount. If I play 6 games, it's going to cost more. So do you understand that the cost is going to become the dependent variable? So the independent variable is the games that she is playing. Now, the independent variable is what's going to go on this side. It's going to go within the problem right here, okay? So we've got two constants. We have the cost of the game here, and we're going to add on the cost of the shoes. Those are constants. It's not going to change. And the shoes is just a one-time thing. That's why we added on. But the cost of the games are going to change. Or I should say the cost that you pay is going to change depending on the number of games. So the total cost is my dependent variable, okay, dependent variable right here. So C, the cost is going to be dependent on $3.25 times the amount of games that she plays, plus the number of shoes. Are you following me so far? Okay, so the equation C is equal to $3.25 times G plus $2.50 represents the total cost in dollars that Lorelai spends if she plays bowls G games, where C is the dependent variable and G is the independent variable. Okay, so there's two examples of how we can build an equation on independent and dependent variables. Now, what happens if I tell you the independent variable? What if I give you a value for the independent variable? And in the order of telling you right here, we're going to say, what if Lorelai played 3 games? 3 games. If I do that, I can substitute. Okay, that didn't come off so good. Substitute for the G. Okay, this 3 is G. So down here in my equation, 325 times G plus 250. I'm going to put a 3 in here. I'm going to substitute. Okay, so now I have to do the math. I have to take $3.25 times 3. So start with that. I'm going to write up here. 325 times 3, 15. I get $9.75. See if I can get that in here. $9.75. Okay. All right. Plus 250. Got to add on the 250 for the shoes. And we end up with $12.25. That period in there. And my dollar sign. So Lorelai is going to, for 3 games, is going to have to pay $12.25. All right. All right. Let's just take one more moment here. Give me just a second here to make more room. Okay. Let's take a look at that share and show page really quick. I'll pull this up. So we're going to take a look at a problem here. Problem number 1, which is about an online bookstore. Okay. We're going to identify the variables. Then we're going to make an equation. Okay. An online store lets customers have their name printed on any item they buy. The total cost C in dollars is the price of the item P in dollars plus $3.99 for the name. Okay, so let's decide here first. The cost, that total cost, whoops, the cost depends on the price. Okay, so I tell myself I can't know what I'm going to pay unless I first know the price, correct? So that means that the dependent variable is the cost. The independent variable is going to be the price. All right, so I'm going to make an equation. I've got an equal sign right here. I hope you see that. The dependent variable is off by itself at the end. The cost is the dependent variable. It is reliant on the independent variable, which is P. The price plus $3.99, which is one of the constants. Okay? All right, boys and girls, I'm not going to do number 2 and number 3. I'm going to ask you to work on these on your own right now. And think about, what do you think? Which one's independent? Which one's the dependent? Remember, the independent has to happen. Then the dependent variable is a result. Okay? All right, boys and girls, happy math.